In this video, we're going to talk about systems of two linear equations in two variables. Let's begin with a puzzle. Suppose you have a stack of 20 cards, each one of which is labeled either with the number 2 or the number 5. And suppose that the sum of all the numbers on the cards is 64. Then how many cards are labeled with the number 5? At first glance, it might not be clear how to solve this puzzle. In fact, it's not even obvious that this puzzle has a solution, or if it does, that solution is unique. But one way that we can make progress is by giving names to the things that are unknown to us. And here, there are really two unknowns. One of them is the number of cards labeled with the number 2. Let's call that x. And the other unknown, the one that we're being asked to find, is the number of cards labeled with the number 5. Let's call that y. Now, we don't know what x and y are, but we do have some information about them. For instance, we know that the total number of cards in our stack is 20. So the number of cards labeled with a 2, that's x, plus the number of cards labeled with a 5, that's y, has to equal 20. We also know that the sum of all the numbers on the cards is 64. So think about it. If there are x cards labeled with the number 2, then the sum of all the numbers on those cards is 2 times x. And if there are y cards labeled with the number 5, then the sum of all the numbers on those cards is 5y. And adding everything up, we must get 64. These two equations in two variables, x and y, are an example of a system of two linear equations. Now, before we get to the solution of our puzzle, let's step back and try to analyze these systems of equations more generally. By definition, we're going to say that a system of two linear equations in two variables is a pair of equations of this form. We have an equation a times x plus b times y equals c, and then a second equation, d times x plus e times y equals f. Here, x and y are the two variables, and a, b, c, d, e, and f are fixed constants. Those are just numbers. And when we talk about the solution of a system of equations, what we will mean is all pairs of numbers, x, y, that, when substituted into any equation in the system, makes that equation true. Now let's ask an important question. How many solutions can a system of two linear equations in two variables have? It turns out that there's a beautiful way to answer that question using geometry. Notice that the solution of a single equation in two variables is just its graph. And if that equation is linear, then the graph will of course just be a straight line in the xy plane. Given a second linear equation in two variables, its solution will likewise be a line in the xy plane, and it follows that the solution of both equations, the solution of the system of these two linear equations, will simply be the intersection of the lines, which in this picture corresponds to a single pair of numbers, x, y. Another possibility is that the graphs of our two equations are parallel lines that never intersect. If that's the case, then our system would have no solutions. Finally, it could be the case that the graphs of our two equations produce the exact same line. If that happens, then our system would have infinitely many solutions, since any point on this line would solve both equations. Let's take a look at an example. Have a look at the system of linear equations shown here, and without trying to actually find the solutions, see if you can figure out how many solutions this system has. It turns out that this system has no solutions, and we can see that by taking the system and rewriting each equation so that it's solved for y. That would make the first equation read y equals x minus 2, And solving the second equation for y, we would have y equals x plus 3. And what we can see by looking at this new system obtained by rewriting the old system is that the two equations represent lines that have the exact same slope but different y-intercepts. In other words, they represent lines that are parallel but that never intersect. So this system will have no solutions. Now, if we take a look at the exact same system that we just analyzed, but we replace the 9 in the second equation with a -6, then how many solutions do you think this system would have now? Once again, see if you can figure out the answer. This time, notice that taking the second equation and dividing both sides by -3 actually gives us the first equation, x minus y equals 2. In other words, the second equation in our system is really just a copy of the first equation that's been multiplied by a constant. It follows that these two equations actually represent the exact same line, and therefore that our system has infinitely many solutions. Finally, if we were to take that system of equations that we first looked at and, let's say, multiply the x in the first equation by 8, then we would get a system of two linear equations that has exactly one solution. And the reason, as you can quickly verify for yourself, is that the two equations would now represent lines that have different slopes and that must therefore intersect at exactly one point. Okay, but how do we actually find the solution of a system of equations? Let us now return to the puzzle that we posed at the beginning of this video, the one with the cards labeled 2 or 5, and get to the solution. Remember that we said that this puzzle can be framed as a system of two equations, which are the ones shown on the screen. To solve this system of equations explicitly, we're going to use a technique called substitution. Here's how it works. Let's take one of our two equations. It actually doesn't matter which one, but the first equation is more convenient, and solve it for one of our variables. Let's go ahead and isolate x. So solving our first equation for x gives us x equals 20 minus y. And what we're now going to do is take this and substitute it into the second equation. When we do that, we obtain the following. 2 times x, but remember, x is 20 minus y, plus 5y equals 64. And by performing this substitution, we have now obtained an equation that involves only the variable y and some numbers, which we can solve for y. Distributing the 2 gives us 40 minus 2y plus 5y equals 64. Subtracting 40 from both sides and combining the y terms together gives us 3y equals 24. And finally, the answer that we're looking for, y equals 8. So the answer to the puzzle is that there are exactly 8 cards labeled with the number 5. And by the way, we can go ahead and solve for x as well by substituting y equals 8 back into the first equation. That immediately gives us that x is 20 minus 8, or 12. So we can also say that there are exactly 12 cards labeled with the number 2. And in fact, this system of equations, as we've just shown, has exactly one solution. The solution is x equals 12 and y equals 8, which can be represented as a single ordered pair of numbers, 12, 8.